It's a very good evening once again. We're still continuing on our lecture series that is on the topic torsion and strength of material. As earlier on, I explained in the previous video that I'm going to give you a simple example that will help you to understand the torsional equations. First of all, here is the question that we have. What should be the length of a 5 millimeter diameter wire made of aluminum so that it can be twisted through 360 degree of maximum allowable stress, 42 megapascal. We are considering G, that is what? The shear modulus to be 27 gigapascal. As we dive into the explanations of this, how it is done, we need to remind ourselves about torsional equation. That is torque T out of pole moment of inertia J is equals to shear modulus G theta out of L is equals to tau, that is shear stress, out of, that is what? The radius. Now, according to the question given, what do we know? First of all, we have been given, let's take note of what is given. Given that the length of the diameter, of a 5 millimeter diameter, meaning that what is given there? Diameter is given to be 5 millimeter. Now, what else do we know? Wire made of aluminum so that it can be twisted through an angle. So the angle of twist, in this case theta, is given to be 360 degrees. Remember, in the previous video I told you that theta must be recorded in radians. So that means this should be converted in radians. 180 is pi. Another 180 to make 360 will be 2 pi. In what? In radians. What else do we know? The allowable shear stress of 42 megapascal. So we know that tau, that is what? Shear stress is 42 megapascal. But if you see the word mega, know that it is 42 times 10 raised to the power 6 Pascal. Pascal is Newton per meter square. So you need to know that. Then what else do we know? G, the shear modulus, is given to be 27 gigapascal. 27 gigapascal. Giga means 27 times 10 raised to the power 9 Pascal. These are the informations given. What do we have to find? The question is, what should be the length? That means we don't know L. And which equation or which expressions contain L? It is what? This expression. What else do I know? Tau I know. That means I have to consider what? This part of the torsional equations. If I take that part of the torsional equation, I will substitute it here. Do I know G? Yes. My G is 27 what? 27 times 10 raised to the power 9. And then times theta. Do I know theta? Yes. My theta is what? Angle of twist is 2 pi. Then I'm dividing it by L. L is what I'm looking for. So I leave it as what? As L is equals to tau. That is the shear what? The shear stress, which is given to be 42. This case is 42 times 10 raised to the power 6 Pascal. And then divided by what? By our radius. But now, in this case, we don't know the radius, but we have been given diameter. So you know that radius is equal to diameter divided by 2. So that means where I have the what? Where I have the diameter, it is equals to what? Radius. Radius will be equals to diameter divided by 2. So when I divide 5 by 2, it is 2.5. But this is millimeter. So to convert it to what? To meter, I have to multiply this by 10 raised to power negative what? Negative 3. That means my what? My radius, this is equivalent to my R. So my radius is going to be equals to 2.5 times 10 raised to power negative what? Negative 3. We are asked to find the value of what? Of L. In this case, if you make L the subject, we're going to have 27 times 10 raised to power 9 times 2 pi. When I cross multiply this, I will have times 2.5 times 10 raised to power negative 3. Divide all the thing by what? By 42 times 10 raised to power 6. You find that our expressions, when you calculate this and carefully, we're going to obtain 10.098. 10.098 in what? In meter. And this is how simple the question was. This is the first problem we're solving under this version. Please don't forget to subscribe so that we'll get to another question that is much more advanced than this, and you understand the concept as you continue. Subscribe to Hudson Engineering Academy. Always the best. Thank you.